so it helps um, style it according to the to type 8. But I don't know in JavaScript
Yeah, I
if
use
VS Code has that.
Now, there's a
ESLint.
difference between styling the source code and actually making it conform. That's two different concepts.
I meant confirming to the standard.
There's probably an ES6 plugin that helps you with conformity.
Yeah, we use ESLint and Prettier.
ESLint, okay.
Yep. ESLint and Prettier combined, it's really great. All right, let me go ahead and share this link with you. I already have the easy one done. Does anyone else have the easy one done yet? I know I just posted it, but
it's pretty easy if you have even a little experience.
yeah. I like the easy ones because I can't wait till I get to that point with the mediums where I'm creating multiple solutions in a short amount of time. Almost. Give me like 30 days, bro. At least with the array problems, you know?
I get a little bit confused between arrays and lists because in Python, like an array, like a list is an array in JavaScript, or
Yeah.
is it the same thing, or is it?
Well,
is it...
generally speaking, an array has an index, so you can go directly to a certain member because of that index. You can go to the third element. A list usually doesn't have an index, although it might.
In Python, it does. In Python, a
Yeah.
list is just an array. Yeah.
Oh, I see.
Yeah. Python calls an array a list, but a list in another language might be something else, you know?
Yeah, some languages have what's called an ordered list.
And a hash map is a dictionary. A dictionary in Python is a hash map in JavaScript, correct?
Yeah.
Okay.
Yeah, I haven't
It's
gotten
a
into.
dictionary in C# also.
Gotcha.
Oh, I see.
Used it many thousands of times.
All right. So we will share the easy ones afterwards. We could go over a couple different solutions. I did share the link. Let me see if anyone's in here yet. No, no one's in here yet. I posted the link. We're in the lobby right now. Just above the lobby is the APIs channel, and just above that is the chat channel. So if you click on the chat channel, I posted a link for the live share. So anyone who wants to join code along with me, you can just click that link. You'll pop right into my code editor. For those who are newer or haven't done live share yet, it's like Google Docs. So when I edit code on my end, you're going to see it changing on your screen in real time. And same thing, if you type something into the editor, I'm going to see it happening in real time. So it's a really great collaboration tool. So give everyone a couple of minutes and then we'll go over these problems. I'm trying to learn the shortcuts too. Like I waste so much time just with my mouse clicking in different spots and highlighting. Like I really want to learn how to use the keyboard good because I saw someone who comes to our in-person meetup. They know how to use the keyboard for everything. They never touch their mouse. I'm like, oh my goodness, you do everything so quick. Blew my mind.
It's also, I think it's also like knowing what to write helps a lot, because I did do I did practice just like typing in the word per minute, but sometimes it's just like I don't even know what I'm doing, so it's like kind of useless.
Yeah. All right. All right, we got Everett, Omar, Olive, Kevin. All right, cool. So I will pop open this problem. Let's see what this is all about. So we have a matrix diagonal is a diagonal line of cells starting from some cell in either the topmost row or leftmost column and going in the bottom right direction until reaching the matrix's end. For example, the matrix diagonal starting from mat 2, 0, so 2, 0, so that 1, where mat is 6 by 3 matrix includes cells mat 2, 0, mat 3, 1, and mat 4, 2. Okay. Given an M by N matrix, mat of integers, sort each matrix diagonal in ascending order and return the resulting matrix. Okay. Let's see. So if we put in...
So the output array, it's worth noticing, is 3 rows of 4 columns.
Yes. Oh, but you want to sort it from...
So it always goes by row.
Gotcha. Yeah, so the 0 is 1, 1, 1. First index is 1, 2, 2. No. How are we sorting this? Let me wrap my head around this. Because we have a 1 in the last row. It's just kind of throwing me off.
Well, by the description and also by the ordering of the output, I would think you start in the top left corner. You do that row 1, 1, 1, 1, and then the next row 1, 2, 2, 2, and then the bottom row 1, 2, 3, 3. As far as making the output array.
Yeah, so in this last one, you're taking the lowest, the element with the lowest value and putting it in the topmost left, right? And
Yep.
then
You go across that top row the same way, smallest number possible. And then down in the left column, the 0th column, go down also with your smallest numbers.
hold on, let me do.
And then move, down 1 row and over 1 column and do the same thing again.
All right, so that's what the second one was when it was passed in. Then
So how would we store this matrix? Is it going to be a hash map with key and value pairs?
I don't see that would help.
I don't see the diagonal pattern in the second one though. That's what I don't understand because.
Well, if you look at any given cell, the arrow goes down and right. I hate saying down and right because they're kind of arbitrary, but
Yeah, I know what you're saying. So.
you're increasing the column and the row every time. Well, if you can, until you hit the edge of the.
So how do we get a 4 and
limit.
a 1 over here then? Hold on, let's check out the constraints. Maybe there'll be a hint here. So M equals mat.length, so how many different columns there are. N equals mat.i.length, so how many actual rows across there are, right? M is going to have at least 1 column, N is going to be at least 1 row, and it's going to be up to 100 across and 100 down. Then mat ij is going to be a number from 1 to 100. Huh. This is interesting.
Oh, nice.
I don't understand the problem, honestly.
Well, step 1 is take your input and just throw it all into one big array and sort it.
So if you look at the
Cool. That's a good idea.
after result, if you look at the after matrix,
Um,
all the number on one red arrow are sorted. So our goal is to sort all the element on one red arrow.
Ah, gotcha. Okay. So 1, 2,
so
3.
we're sorting diagonally. Is that correct?
Yeah.
Yes,
Uh,
which is a
Okay.
weird concept, but it's really not that
So
hard to do.
how do we decide that a 5 goes here and a 17 starts this diagonal?
I don't think.
so
Oh,
the way I solve it, like I haven't implemented code, but I am like I came up with code. So
How do
so
can you just answer that question first though,
yeah,
Omar,
I
if you
don't
talk?
think
yeah.
Jimmy.
What's the question?
I don't think you're just sorting diagonally. Like the first row is not sorted. It's just like you're going like so you're looking at like 11 or for example 25, 17, 14, 68, 50, and then you're just sorting these and 17 uh, sorry, 17 tends to be smaller than the rest, and it's
Okay.
just
That makes sense.
so you're just
Okay.
going diagonally,
So you're taking
and
the numbers that exist in this line right now and sorting them.
yep,
Yeah.
yep,
This okay.
and 5 goes, yeah. I think
So
that's how
Okay.
it's
That makes
being
sense.
done.
if you draw
Some
an arrow
wrong.
from every element, you will make sure like all the elements on one arrow are
Oh yeah,
sorted.
that's better.
So
that looks better.
uh, so what was the question you told me to answer?
I was just asking, how do you know that this that the 5 goes here, and it's because this diagonal line has 11, 55, 36, 25, and 5. So you have to bring the 5 up to here. You have to bring the 11 here, the 25 here, the 36 here, and the 55 here. So any number that's on this line is staying on this line. We just need to sort it.
Oh, that's icky.
Exactly.
Yeah.
So
Okay.
Yeah,
like
my algorithm that I was envisioning won't work then.
so my first idea was coming to mind is to loop through a left edge on the top edge. And from each element, it's like a drawing an arrow and bring the minimum value to it. So when I am here, I draw an arrow and compare all the elements on this arrow and bring the minimum value. When I reach to this, I draw an arrow here this way and bring the minimum value, and so on from here to here to here. Next iteration, I will loop from here to here to here and bring the minimum value.
How are you finding the minimum value?
So let's say I reach to this element.
Yep.
So I compare. It's like it's a simple sorting algorithm. So I create a temporary array. First, push to it 11, then push the next index for I and j, which is 32, then increase the index I and j and push the next element 31, then increase the index I and j. I reach to this, so it's 33. If I increase the index I and j, I will reach to undefined, so I will stop. Then from this temporary array, I will bring the minimum value and swap it with the first value.
So how do you get these digits into this array?
You add one to the row and add one to the column each time
Okay,
So
so yeah. Until
you run out of rows or columns.
you're out of bounds.
Yeah.
once you get undefined, you stop.
Why can't you just sort the subarray?
So
And if you remember your values
exactly.
as you create it, you just put them
Yeah.
back in that order.
So yeah, maybe this is more efficient way if we like while let's say while building this temporary array, instead of pushing values, we could push the index of it and after sorting the index as I and j. So after sorting it, we like play with the original matrix. Just let's say like I start the I and j of 11 and for every element, and then I sort the array. I will go to the first sorted element and look up for its I and j in the original matrix and replace its value, and so on. So yeah, so I think like Kevin way is more optimized. So I just really need to loop through those elements from here to here, like left edge, then the top edge, and compare building temporary array for each element that go with the red arrows, and then sorting every red arrow. Then, after sorting, replacing it with the original matrix. So, if I do this way, I should get a result. So, first step is to loop.
All right, can you write the pseudocode?
Okay, so loop from bottom left element to top left element to top right element. Here to here to here. So for every
We actually only have to loop from the 22 to the 52 because the 7 and the 84 will never move.
okay, yeah, so that as another optimization. So for every element, start. Sorry.
Is it always going to be like the same number of rows and columns, or is that changing?
No, it could be anywhere from 1 to 100.
I see.
So for every element, start building temporary array. This temporary array building by keeping increase I index and j index by 1
Okay, so if
until
The
undefined.
interesting thing about a diagonal is the I and J are always the same.
Until undefined for every value is either I or j, like Kevin said, so we don't need to store both.
so let's say we start at this 22, right?
Uh-huh.
because we already know that 84 is going to be the same. So we start at whatever the column number is minus 1, which would start us at 22. So we get to 22, right?
So let's say we start with matrix 0, 1, 2,
Yep.
3, matrix 3, 0. For
Yep.
the next iteration, you push matrix 4, 4, 1. So you will reach to 28 if you increase the I and J. If you start with matrix 14, which is matrix 2, 0, next iteration, you will push matrix 3, 1.
Yeah.
Next
And then the next
iteration will be matrix 4,
4, 2.
2.
All right. So how you getting from this matrix to, or how you getting from this element to this element?
So just increase I and J by 1. So 2 plus 1 is 3, 0 plus 1 is 1.
So you're looping.
Yeah, so you reach to this element while looping the edges. Remember, we start by looping the edges. So you pick the first element while you are looping through those two edges.
All right. So we are going to loop through the left side of the matrix starting from the bottom, right?
Mm-hmm.
Working our way up the left side toward the top. When we reach the top, we'll move from the left to the right,
Mm-hmm.
remaining on the top. But are
How
these...
can we?
What's up?
Sorry. How can we get the last row in the matrix?
You mean on the top?
Is this the? No, I mean the bottom one.
This one here?
Yeah.
So we actually don't need to target the 84 or the 7 because those, you can't see their diagonals, so they're never going to change positions.
So we start from matrix dot length minus 2, 0.
Oh, I see.
So
So it's the
is this...
second index.
What's up?
Okay. So we start with the 28.
Yeah, it'll be matrix, if you're looking at my screen, matrix I dot length minus 1. Because matrix I dot length is going to give us the number of columns. So
Yeah.
if we do
Minus 2
matrix I minus 1, it's going to give us, like this one has 0, 1, 2, 3, 4 columns, which is actually 5, but it's 0 indexed. So if we do matrix dot length, it's going to be 4, so it'll start on this one right here. But if we do minus 1, it'll actually start on the third.
So this minus 2. Because it's 0 index and we don't need to start at the last one.
Yep.
So matrix dot length minus 2.
Okay, cool. 0. Yeah. So that's the one we're starting at. And then we basically just move down and to the right as many times as possible until we reach an index that's undefined. And once we reach an index that's undefined, we have the array that we need. We can sort the array and we can place each element back in sorted order, right?
Exactly.
Okay.
And
So-
all we really need to remember is the upper left index of the the element we started with, because you just add one each way.
So moving from this bottom left to the top is going to be one while loop, and then the top moving from the top left to the top right is going to be another while loop, right?
Yes.
Yeah.
Okay.
So
Okay, so we could go ahead and just create a little structure here. Okay. So, wow.
So I just said from bottom to top, the way I imagine it, but you could start from top to bottom. Like you could start from 0 to matrix.length minus 1. So the direction don't make any difference.
Right.
But I say from bottom to top because I imagine it like the red arrows in their figure.
Yeah, that's really not consequential. There's only so many diagonals, no matter which end you start on or whatever.
Yeah. Is and these m.length is mat.length, n is mat I.length, m and n.
So n is your rows, or my eyes, m is your rows and n is your columns.
Okay, yeah, and they could be different numbers too. Like n might be 4, n will be 3. So there would have been an easier solution if they would have been equal, but okay.
Yeah, it's the same solution.
All right, so we're actually going to need a loop inside of the while loop though too, right? Because not only are we going to have to run the while loop.
Yeah,
Yeah.
you've got to gather your diagonal.
Yeah.
So I think the first thing in your while should be remembering the coordinates of the upper left element of your diagonal.
Can't we just do a for loop until we get to
Yes,
this
you could
length?
do a for loop.
Yeah,
Yes,
that's what.
it's probably better, truthfully.
Yeah.
You don't have to worry about a breaking condition.
Well, I is less than mat I dot length, right?
-2.
Minus
Minus
1.
2.
Or, yeah. Yes, or equal. Okay.
I plus plus.
And I guess they could throw you, by their own rules, they could throw you a matrix with only rows, or with only columns, a one-row matrix, but I don't think they will. I guess technically it's not a matrix if it doesn't have columns.
So we're starting at the top left. Then we want to go through another for loop while mat ij is still defined, while we're still getting back a value. And every time we encounter another element, we push that into an array, right?
Yeah, but first let's define a temporary empty array. Because we some temporary array to hold our path.
Yeah.
Diagonal path.
Right. And also an anchor position.
Define temporary array. Then loop from top left to bottom right until we reach an undefined cell. And on each iteration, we're gonna
push the element you
the
find.
element onto the temporary array, and then
Increase ij.
What's up?
Increase ij by 1.
So we're gonna be increasing.
Not this I. So let's here define.
If you're going down the left edge, then you're
Position FMN. And
so yeah,
at each like
we're fixing M at 0 if we're going down the left column.
Yeah, but if we edit I down here, it's gonna edit this I. So
no, I use MN.
oh, so you're storing the value of I and J inside of M and N, right?
Yeah, so I initialize N and M, like initialize M as I
Yeah.
and N as 0.
Cool. All right, and then so we're gonna push the array onto that, and then after this loop right here, we are going to
Sort the array.
we're actually gonna have to loop again though, aren't we?
Yes,
No.
it'll be the same loop basically.
So why to loop again? Why not?
Because
Just
if we're looping from top to bottom right to store each one of these values inside of an array, we still need to push, or we still need to splice these
Yeah, we need
values
to
back onto
splice
this.
those sorted values back into your
Yeah,
matrix.
yeah.
right?
Yeah,
How are you
we
gonna do that without another loop?
need.
Unless
So
we did it while we were going through the first loop, but we don't know what's in
Right, you
the
don't
array
know.
yet.
And yeah,
no, we really need another loop. Yeah.
So loop from top left to bottom right till we reach defined cell. Splice in elements from temporary array, right?
Exactly. Yeah.
And then we start this loop over and we go from I, so we're gonna drop down to this one
let's
right
see
here,
this.
right? Yeah,
Come on,
let's go
brain.
ahead and try to get this block of code working, and then because this should cover everything on the left side, and then we'll just have to get things going from the left to the right, working right.
Exactly. But for this for loop, it's better to make it a while and keeping it
Right. Well,
while
it's ugly either way. It's ugly.
let's make the temporary array. Let's initialize m equal I, m equal 0.
It's just easier for me to read.
So m dot push map m in
Yep.
while or let's say y mat m plus 1 or y mat.
Actually,
Yeah.
well, no, go ahead. Well, I was thinking, while true might work, and then we just say if M is, or whatever our.
Yeah, so let's make it easy. I get what you mean, like putting
If
like
M is greater than length, or N is, well, And it'll never be greater than length. It's only M we have to worry about.
N dot first temp M and M plus 1 M plus 1 is the while loop and temp dot sort, and then creation M equal to I, N equal to 0, and then Y.
Hold up, I want to make sure that this stays easy for people to read. So, push the element to the temporary array. Increase M and N by 1. Does anyone have any questions about this?
So I guess this way will achieve this half of the math. I hope.
Right. And then we just turn it 90 degrees and do the other side.
Wait, what are you
Where
doing
we're
right
stepping.
So right here I replace the element of Mn of the matrix with the n element of the temp, because if like when we select this one,
Hold on, what's this push right here though? You're pushing.
oh yeah, no, it's wrong.
Oh, okay.
Yeah. It's a reverse push.
That's one another problem.
Okay. Sort
So
temporary
I'm thinking
array.
about, is there any edge cases where it failed?
Reset and let's see. So while MN, so we're going from the top left to the bottom again. Temp N. So the first one. Okay. Yeah, that looks about right. Four. Let's output this to see if it works. Just for this, what we got so far.
Please don't test me. I am worried about the result.
I can't be that bad. I think we
Testing
got-
is the fun part.
Yeah. All right. So that should be this for loop right here. So let's go ahead and test console.log. What is it called? Mat, right?
Yes. Yeah, we're directly modifying it. So yeah.
We need to get
Just
ready.
knock out that second. There you go.
We
Well,
got
and your example stuff at the bottom, as usual.
we got an error in here somewhere. Oh, it's right here. Okay. And cannot read properties of undefined reading 3. So.
Oh yeah. Okay. So we cannot like test Mn.
So can we just do equals undefined, or it does not equal undefined?
So no,
because it'll still try and make that reference.
So
we're just gonna have to test.
Yes.
Well, yeah, we got to test them both.
That's gonna be the same thing though. Yeah, no, that's not making a difference, Omar.
We're gonna have to look at the M and N values directly.
So if M is not defined, this will quit. Don't try for N, like, because this false, this will exit. So if this true, it will check if this true. So I think like this is the solution. So,
yeah, but if every time
it checks both, you can't stop it from checking both. I know when you read it, you think it only checks the first one, but it doesn't.
so I
What's the issue again?
We could just do this because we know we're moving from the top to the bottom, so we know that once we hit mat I or mat, in this case it would be 0. We're increasing 0 by 1 every single time. So once we hit mat n dot length, so if we do mat
Yeah.
n dot length minus 1, well,
So, but why you consider mat m and mat mn is won't work?
yeah,
So
well,
because
because mat n or mat 0 dot length is how many rows there are from the top to the bottom. So once we hit that bottom, we know we can't go any further. So no, this isn't done. I know that.
I mat n minus 1. I really
Yeah.
can't get the
N,
idea.
well, N is less,
Yeah.
but you
Right.
also have to say M is less than
Yeah.
No, I don't think
the
n
actual
matters
mat
here.
dot length.
I don't think n matters here because n is going to increase by 1 with every iteration, right? So we're starting at 0, going to 1, going to 2, starting at 0, going to 1,
Okay, I'll
going
buy
to 2,
that.
going to 3.
When we go across the top, though, it'll matter.
Yeah, so we're gonna have to actually, we can't use mat n dot length on this one down here. We'll use mat dot length.
Right.
Yeah. Okay. Yeah, that should work. And then same thing on this one. Let's see. Well, mat n dot length cannot read properties of undefined. Reading length mat n. That's strange. Mat 0 dot length.
It's getting where N is too big, and
So,
yeah, we need to store the max value of the rows and columns ahead of time.
so, like, but I have like one question. Why mat m and mat mn not working? Because this follows this statement. So if mat m is not defined, it won't continue to check mat mn. But
Who
if
says that? Where do you get that? Where do you get that idea?
Because
so,
both of these have to be
no,
true. If this isn't true, it won't even go to the second one. Yeah, you're right.
Says who?
Says
so if
JavaScript
we
documentation.
if we use one and, it will check both. But if we use two and, it will check the first one.
Yeah, if this is
If it
false,
is
then it'll never go to the second one. Yeah.
Well, except it does, doesn't it? I mean,
No, this is no, you're right, because now we're not getting stuck here, we're getting stuck up here. So for while I is less than mat I dot length minus 2. So for some reason mat I is undefined.
So why mat I? Why mat dot length? So we don't need to put mat I.
Yeah, we do, because we're moving to the bottom. We're moving down.
Yeah, it's like
Mat
yeah, it's the number of rows, so it's that just mat dot length.
Oh yeah.
tree.
No. Okay, so this is we're console.logging mat, and we are still in the same exact order.
So no, the mat is this is sorted. So we have 84, we have 22 before 28, we have 14 before 27, before 75.
We don't have 5 on the top left. So we're sorting everything except this middle one.
Yeah.
Oh yeah, you're right.
So,
The rest is being sorted though.
so we
So we didn't include that first one.
mi n0. So if I0 m0 n0, so temp dot push 5. So
Yeah, so we're never even processing this row, I don't think. So while Matt, so we're starting with m equals I, right? So m equals 0, n equals 0, temp push mat m n. So that should be the 11.
Should pick up the first number. Yeah.
Yeah, then increasing it by 1, sorting it. We're resetting m and n to 0 and 0. While mat m, yes, so that looks good. And then while mat m, is there a reason why this while loop isn't running on the first one?
so
Oh, because mat m is 0, and if it's 0, it's gonna return false.
already.
Yeah. So once we increment I to 1, then it's actually gonna process it.
This.
Yeah, that should work.
So let's just here console.log. I am in 1. Console.log. I am in 2.
Let's print out m and n too, just so we could see. Okay. Yeah.
So let's console.log the temporary and before and after sorted, after being sorted.
Say that one more time.
I will console.log the temporary array before and after sort.
Yeah. All right.
Yeah. Look like it's sorting.
With the A, B thing. A minus B sort.
What's up?
You know how JavaScript sorts numbers? It sorts it in a weird way unless we put in, yeah.
Oh, yeah.
That called.
There we go. 5, 11, 25. Yep. There we go.
Yeah.
Cool. Let's
Wow.
take out some of these console logs. Nice catch. All right, so now we're basically doing the same exact logic, but we're moving from this one to the right, right?
Yeah.
So do you want to just copy and paste this?
Yeah. Stepping in instead of M.
Yeah.
Well, I mean, you're stepping both, but I mean, you're keying off of N instead of M.
We're
It's
making
a little bit different.
a couple modifications. So if we're let I equals, we're starting at
I,
1 on this one, right?
Yes.
I have to go, Jimmy. Thank you so much.
Yeah, for sure. Have a good one. Chat with you soon.
Thank you. Bye-bye.
And then we are going, we're not going to mat length dot 2 though on this one, right?
Nope. You got to do the other side. You got to go number of columns.
So you could just do it for 0
Yeah, 0
to
will
not
work.
because
Oh,
the
yeah.
same number.
Yep.
Just do that. Avoid undefined.
So we have our temporary array. Let m.
Now M will be 0 and N will equal I.
Yep.
And same thing.
And then you have to fix your while.
So maybe it will work just by swapping M and M.
Let's get a console.log mat going here. You don't think that you think the only thing we have to swap is M and N here?
I'm iffy, but give it a run. We have nothing to lose.
Yeah, run it and see.
Oh, oops.
This is working though.
Yeah, as far as it went, it works.
Yeah, and then we get undefined as the last one. So
You do have to
we
fix up that while a little bit.
So maybe we don't need anything. We don't need anything other than changing. I don't know.
No, you're gonna have to change those whiles.
So let's think about the first element. So if we are at 25, we are looping from I equal 1. So M, we should choose the 25 is the mat 0, 1.
yes.
So when I equal 1, it will choose the mat and N0. So
Yeah, so we need to swap mat and M here, right? Because
yeah,
0, 1.
and we need to swap this here also.
What about right here?
Yeah, here and N. Okay.
And right here?
Mm-hmm.
Yeah, both loops are the same.
And same right here?
Yeah.
Yep,
What about
everything's 90 degrees. So yeah.
temp M? No, N. Okay. That's what caused the problem. We only don't need to swap this. Okay.
Ta-da!
Wait, what's this 4 doing down here? Yeah, the 4 is supposed to be... Actually, the 4 is right there. 17, 20.
So let's return and console.log the
We
temporary.
probably need to clear out our
Oh, because
we're doing temp is empty inside the 4, so that's not it.
we're still resetting that right there.
No, but it's doubled up to 8 also.
Yeah.
Or are there 2 8s in the input? I can't tell.
Nah.
So let's log the temporary here. We'll see what happens. Maybe we
So n equals 0. Mat n 0. So that's one array. It's not with the undefined. I'm not 0.
Doesn't help that the printout garbles all the columns.
Yeah.
So should this to be M? So why this here M and this N? So really concerned what should it should be like if N is 0. Yeah, mat N. So here mat M wrong. We want to check mat N. So can you run it now? Because it was sorting but not swapping.
Yeah, we're still
Have you run it after I
seven's in the right
corrected it?
spot. 52, 69, 1, 8, 15, 4.
It's hard to keep the diagonals when they're staggered like that.
Yeah, I think this is actually correct though.
Yeah. Okay. So let's try it on LeetCode.
Yeah,
Just
because 7.
put a space in front of any single digit, and it'll line up more or less. Proportional fonts still screwed up a little bit, but
Yeah, so 52, 69, 1, 8, 15, 4, 45, 58, 66. Yeah, that looks right.
post it.
Mm-hmm. Oh yeah.
I want to optimize
Okay.
this so bad.
People would watch
Well,
this on Twitch.
as nasty as it looks, it's pretty fundamental.
Yeah,
There's
I know.
not much you can optimize.
It work on LeetCode.
Oh,
For the test case, I haven't submit yet.
oh, take out the console logs IMN. that's what's throwing it off.
We're just returning Matt, right?
Yeah, but look at all the console logs. It's calling that
Yeah.
output, saying wrong.
Yeah. Well, it ran. Let's see if it submits.
Yeah, we passed it.
Nice. Nice. Yeah, that was a fun one.